Hi guys. Hi. So what we're doing is my science project. I have my awesome alien stress ball, and so what we're doing is sorry, I kind of knocked the camera. Is Sir Isaac Newton's first, second, and third laws, which the first law states that an object will remain at rest in a uniform motion in a I'm reading this off of Google.
And action.
I'm reading this off of Google, so stick with me here. His first law states that every object will remain at rest or in a uniform motion in a straight line unless compelled to change its state by the action of an external force. Let me translate that for you into non-nerd talk. So I'm kind of a nerd. Which means that this ball will continue to stay in motion until a force acts upon it. So this ball will continue to stay here until I throw it. Like that. And that is the first law of motion. So it will either continue to go up, and so gravity, which is the force that keeps us all sun Earth, will bring it down, or it will stay here until I pump it up. So that is Newton's. Sir Isaac Newton's first law, though that's kind of didn't create it, but we just named it after him, and that's besides the point, and that's for another video. Maybe, if I ever make another video of this. I don't know. Okay, now, Newton's second law. Okay, and his second law of motion is, which I'm going to end up demonstrating with a ramp, is that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and it doesn't matter the mass of the object. So, non-nerd talk. It kind of means that it will continue, like, from, here's my hand, ball, the hand is kind of off the camera, that, I guess I don't need a ramp, but whatever, the ball will continue to accelerate until it hits my hand. So, and it's accelerated by gravity, because gravity brings it down, Earth. So, it continues to go faster and faster from the time I drop it to the time I catch it until it's done. And no matter what the mass is of a single object, so let me just pause this for a second. I'm doing this in my classes, so pardon the noise. So if I drop this book, this heavy physics science onto my lap, it still accelerates in the same rate as the ball. Ready? Like that. And that kind of hurts.
We're damaging science materials.
So, now, off to Newton's third law. Haha. If only I was doing the sixth law. But I'm not. That's a video for another time. And please, pardon the noise in the background. I'm doing this in school, so. Now, what his third law says is that for every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces of the first object equals the size of the force of the second object. Basically, it means that for every action, there is an equal and opposite reaction. Whether it be a good reaction or a bad reaction, it is still equal and opposite. So, when I bounce the ball, here, let me see if I can do this, onto my stool here. It comes up, with the same force as it bounced it. There you go. And that's why you can't see it going down or coming up, because it's bouncing at the same force as it was as gravity brought it down. So, it bounces with an equal and opposite force of the first of when I drop it. If I throw it harder, it still has an equal and opposite force. And no matter how hard I drop it, it still has an equal and opposite force. And that's it. And that would be Newton's first, second, and third law. I'll see you next time if I make another one of these. Depends on if I have to make another project. And again, I do apologize for the background noise. I think I'll go to editing and see if I can tone that down a little bit. If I can't, then I might just put music in the background or something. I don't know. Hope you guys enjoyed. Bye.